This is the solution video for Unit 8 review, problem number 7. All right, so this is a big one, right? It's got A, B, C, D, E, and F. So consider the region bounded by x equals y minus 4 squared plus 1 and x equals 5. All right, so first of all, we need to understand that this x equals y minus 4 squared plus 1 is a parabola that is facing to the right. Okay, now what's the deal here? Well, it has been shifted up 4 and to the right 1. So if I do that, I go up 4, all right, and to the right 1. So I have this, and it is facing to the right. Now, x equals 5 is a vertical line, right? So we're talking about this region here, right? And revolving around all these other places, right? So let's start off with, okay, now I'm given this in x equals, right? And so it's going to make the most sense for me to use a dy, right? Because these are already given here. I don't want to solve this for y, right? Because then I'm going to have, a plus or minus square root, and then I have to deal with that. So I'm just going to stick with a dy. All right, so what does that mean? Well, if I'm going around the x-axis, so let's start with the x-axis, right? So if I go around the x-axis, that means I have a parallel, right? So this is going to be using the shell method, okay? All right. So anything that is horizontal is going to be the shell method, all right? Now, what about the y-axis? Well, the y-axis, okay, is right here, right? And so that's going to be perpendicular. So now I'm going to use the washer method, right? All right, let's go here. Y equals -3. Y equals -3 is a horizontal line. All right, so y equals -3, horizontal line once again. And so that is parallel. And so we're going to use the shell method. All right, let's keep moving. Y equals 1, right? Y equals 1 is a horizontal line as well, right? And so that is also going to be the shell method. All right, and then what about x equals 7, right? X equals 7, well, that is a vertical line over here, right? And so that is perpendicular to the dy, and so that is going to be the washer method. And then x equals -1, okay, over here, and that is also perpendicular, right? So that is going to be the washer method. Now, for the washer method, remember, I'm going to do pi times the integral, parentheses with respect to y, and then I've got big R squared minus little r squared, right? So I'm going to do that same setup for each of these. So washer method, pi times integral of parentheses dy, big R squared minus little r squared, all right? Over here, x equals 7, right? So that's my setup as well. Pi times integral of parentheses with respect to y, big R squared minus little r squared. All right, and then the shell method is going to be the same for each of those. So shell method, 2 pi times the integral of radius times height with respect to y. All right, let's keep going. Shell, 2 pi times integral of radius times height with respect to y. And then lastly, 2 pi times the integral of radius times height with respect to y, right? So I have them all kind of ready to go, and now I just need to fill in the details. All right, so next things, okay? I need to know these points of intersection, okay? So I know what we're integrating, right? We're all integrating with respect to y, so I need to know the lowest value to the highest value. So how do I find that? Well, I'm going to set the two equations equal to each other. I'm going to set 5 equal to this. So 5 equals y minus 4 squared plus 1. So I'm going to subtract 1. I get 4 equals y minus 4 squared. So I'm going to square root. And so I get plus or minus 2. So plus or minus 2 equals y minus 4. So now I'm going to add 4. So 4 plus or minus 2 is y. So 4 plus 2 is 6, and 4 minus 2 is 2. So this is going to be at 5 comma 6, and this is going to be at 5 comma 2, right? And so now all of these are going to be integrated from 2 to 6, right? So every single one of these is 2 to 6, right? Because we're integrating all of them with respect to y. All right. So now the next thing. All right. So let's start off with A. All right. I'll do all the shells together. So the x-axis. All right. So shell. So how far is the dy from the x-axis? Remember, that distance is always y, right? So I'm going to take y minus the axis of rotation, which is 0. So y minus 0, is going to be my radius. And then my height is the upper boundary minus the lower boundary. So the upper boundary is x equals 5 minus the lower boundary is that curve, right? Which is the y minus 4 squared plus 1. So you got to make sure you use parentheses appropriately. Now, remember here in this one, I have y minus that and then the plus 1. So I distribute that, and I actually have 5 minus 1, which is 4. So this height could be 4 minus the y minus 4 squared. And you see in my answers, I actually have that. Okay. And then, of course, I don't have the y minus 0. All right. Let's move on to C because that is also the shell method. All right. So now we're going on y equals -3. So now I'm going to take the y for the dy minus the axis of rotation, -3. So y plus 3. And then my height is actually the same. So that's just going to be 4 minus the y minus 4 squared. All right. And now let's go on to D. All right. So now we have y equals 1, right? And so I'm going to take y minus the y equals 1. So y minus 1. And then I have the 4 minus the y minus 4 squared, right? The height. Okay. All right, so that's the shell method. All right, now let's move on to the washer method, right? So now we've got big R squared minus little r squared. So now the y-axis is right here. So now I'm going to take the boundary that is further from the axis of rotation. So the right-hand boundary is further. So we're going to take 5 minus the axis of rotation, which is 0, or in other words, I might just say 5, right? And then I have the uh, nearer boundary, which is the curve. So that would be the y minus 4 squared plus 1, and then minus 0, the axis of rotation. So I'll just choose to leave that off. All right. And so that is B. Okay. Now let's move on to E and F. So E, we are using the washer method once again. All right. So now x equals 7. Now x equals 7 is on the right side. So which boundary is furthest from that axis of rotation? Actually, the left-hand boundary. So we're going to take 7 and we're going to subtract that equation. So that's going to be the y minus 4, sorry, not y minus y minus 4 squared plus 1, right? But then you'll recognize that if I distribute the negative, 7 minus 1 is 6. And so this becomes 6 minus the y minus 4 squared, all of that squared for the big R, right? Then I have minus the nearer boundary, right? Which is actually the 5. And so I'm just going to take 7 minus 5, right? Which of course we can just write as 2 squared, right? And so then I have all of that integrating with respect to y. And so you'll see on my answer sheet, I actually just have the 6 minus the y minus 4 squared minus 2 squared. All right, so that is E. All right, and then F, very similar, but now the x equals -1 is over here. So now which boundary is furthest from the axis of rotation? It's actually the right-hand boundary. So we're going to take 5 minus the -1. So this is really just 5 plus 1, which of course we're going to write as 6. All right, and then this one, we're going to take the nearer boundary, which is the y minus 4 squared plus 1. And then we're going to subtract the axis of rotation, which is -1. So I actually have a plus 1 and a plus 1. So we're going to write that as y minus 4 squared plus 2. And then we square that whole thing. And then, of course, we're integrating with respect to y. And so that is problem number 7.